Hi, my name's Scott Weatherman, and this is my sand project activity. What I'm going to be basically talking about is sand that was collected near Abilene State Park. It's going to be at coordinates 32.14.3 north by 99.53.11 west. This right here is kind of showing you the geology of the region. If you zoomed out, you can see that it is indeed Texas, and here's Abilene. So we have this awesome ability to do this. So this kind of just shows you what looks like around the area. You can see right here there's a lot of stuff going on attributing to this area, and the sand was pretty much from around here. So we have some antler sand with some Cretaceous. We have several different Quaternary deposits, and then the very bottom, the basement that you'll find is pretty much going to be Permian. For that, it would pretty much have to be seen in other areas of Texas or through drilling or whatnot to find what's below that. So real quickly to talk about the history, geologically, what we have is we have the Permian is the oldest. It's a quartermaster formation. It's a shale type rock. You might heard of the Permian Basin, so that's out west, and underneath that is where we have the oil and gas deposits underneath that. And then above that, we have the Triassic layer. It's not exposed. It's pretty much covered up by a lot of stuff, or it's been eroded away through here. There's a lot of erosion that happened over time, especially during the Cretaceous time. And there was a lot of water overlaying. Let's see, the Jurassic period actually is famously known as missing from the record, and it's probably because there wasn't as much deposition going on at that time. It was a little dry and arid. And then you go into our Cretaceous, where a lot of the stuff is from, that we're going to have different interglacials coming up. Different transgression and regression periods are going on during this time. So we have kind of what goes is a finding upward sequence that goes on from a sandstone up into the limestone, and then above that we have what goes on to be the deposits. They're in the Paleogene and Neogene are going to be more alluvial. They're going to be like flood deposits and stuff that come from other places and deposited, and then more recently in the Holocene is going to be primarily alluvial type deposits. We have like right here that are alluvial Holocene deposits and whatnot. Anyway, so I'm sorry I'm going quick on this, but I need to make sure I get through this because the last time it was too short or too long. So real quick, what my lesson plan involves is, I need to make this a little bigger. It's hard to find a next generation standard really for what I'm trying to do, but we have the essential for Texas right here. We compare roles of erosion, deposition, directions of water, blah, blah, blah. Specifically talking about water because I'm wanting them to know about or be able to do a lab on transgression and regression because we just got done talking about it, and going into future stuff would be good. So, focus question, what can the size of the particle tell us about where it came from and about the past? So, you're going to be able to explain geological past based on grain sizes in the rock. Here's some of their stuff that you need to know. We talked about Walther's Law recently. We talked about some of this other stuff, so then you know those things. The summative assessment itself is going to be a lab report that's done from a lab. So they're going to do a lab demonstrating different depositional environments. And the way I'm going to do this is they're going to have to basically be partnered up. They're going to be told observation, and they're going to give a question on what happens with deposit material in different water depths. They're going to then have to develop their own hypothesis, and then pretty much the steps are going to be, when they do the lab, is they're going to be given at least 3 containers. Each container is going to contain water and sediment of various grain sizes, preferably local. It's coarse sand grain, silt, clay size, etc., whatever's there. And what they're going to do is they're going to stir the first one, at least like 1 stir, to just kind of let it set. And that's going to represent deep water deposition. And then they're going to have 2 others that they're going to do 1 stir per 5 seconds and 1 stir per 2 seconds for a minute. And they're going to do this for a minute apiece. And then they're going to basically repeat it 3 times and with that data, they should be able to kind of figure out things look different when there's more water energy. And so that goes with basically depth. So if you're closer to shore, you have shallower depth, you have more wave action, you have more water energy, you're going to have coarser material there than you would have further out in the ocean where things can just kind of settle down without being disturbed. And that's all going to tie together. The last 5 minutes class, obviously they're going to need to tear down and clean up for the next group to start doing theirs. And I just think this will be a great activity for them to do. I'm trying to get them used to writing lab reports. It's something that's important and they need to know how to do, so they're going to have that. And basically just discuss at the very end, in their conclusion, they're going to talk about how it relates to a stratigraphic column that I'm going to show them for the local area. They can see the different sequences, what's going on, and they can get an idea of what has happened in the past in our region to make it look like that. And that's it.